What if I told you that this very moment, your past and your entire future are all happening right now, simultaneously? It's a concept that sounds like science fiction, but it's a very real possibility that keeps physicists awake at night. If every moment already exists, are we actually moving through time? Or is our consciousness just a passenger, experiencing a pre-written story? Welcome to Bizarre Bureau, where today we peel back the curtain on reality itself to ask the question, is time just a stubbornly persistent illusion? To understand this mind-bending idea, we need to talk about Albert Einstein. We all know him for E equals MC, but his theories of relativity completely shattered our everyday understanding of time. Before Einstein, we thought of time like a universal clock, ticking at the same rate for everyone, everywhere. Isaac Newton envisioned it as an arrow, flying straight and true, unchanging. But Einstein showed us that time is not constant. It's relative. Imagine you and a friend synchronize your watches perfectly. Then, your friend hops on a spaceship and travels near the speed of light, while you stay on Earth. When they return, you'll find that their watch is behind yours. Less time has passed for them. This isn't a mechanical error. Time itself literally slowed down for the person traveling at high speed. This is called time dilation, and it's been proven countless times with atomic clocks on jets and satellites. Time is flexible. It can be stretched and squeezed. It gets even weirder when you add gravity into the mix. Einstein's general relativity tells us that massive objects, like planets and stars, warp the fabric of space-time. Think of space-time as a giant trampoline. If you place a heavy bowling ball in the center, the trampoline sags. That's what planets do to space-time. The stronger the gravity, the more space-time is warped, and the slower time passes. This means time moves slightly slower for someone living on the ground floor of a skyscraper compared to someone living on the top floor because they are closer to Earth's gravitational pull. The difference is minuscule, but it's real and measurable. So, if time is different for everyone depending on their speed and location, can there really be a universal now? Einstein himself struggled with this. He once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." This leads us to a model of the universe called the block universe. Picture the entire history of the universe, from the Big Bang to its very end, as a single four-dimensional block of space-time. In this block, every event that has ever happened and ever will happen already exists. The past isn't gone, and the future isn't unwritten. They are just different locations in the block, just like different cities are different locations on a map. Think of it like a movie on a DVD. The entire film, the beginning, the middle, and the end exists on the disc all at once. Your DVD player just reads the data sequentially, creating the experience of a story unfolding over time. In the block universe theory, our consciousness is the DVD player. We experience moments one after another, creating the sensation of time's flow. But in reality, all moments are equally real and coexisting within this cosmic block. Your birth, you watching this video right now, and what you'll have for dinner next Tuesday are all just different coordinates in space-time. This is where things get really unsettling for our sense of free will. If the future already exists, does that mean it's predetermined? If all our future actions are already part of the space-time block, are we just puppets playing out a preordained script? This concept, known as determinism, is a profound philosophical challenge that stems directly from this physical model of the universe. The idea that our choices might not be our own is, frankly, terrifying. It challenges the very essence of what it means to be human. Are our struggles, our triumphs, our loves, and our losses just frames in a film that's already been shot? But wait, not all physicists are on board with the block universe. The world of quantum mechanics, the science of the very small, paints a very different picture. Unlike the smooth, predictable universe of Einstein, the quantum world is fuzzy, probabilistic, and downright bizarre. Here, particles can exist in multiple places at once in a state of superposition. It's only when we measure them that they choose a single state. This inherent uncertainty in quantum mechanics suggests that the future might not be set in stone. Some theories propose that time is not a fundamental feature of the universe, but rather an emergent property. It's something that arises from the more basic interactions of quantum particles. Think of temperature. A single atom doesn't have a temperature. Temperature is an emergent property of the collective motion of many atoms. In the same way, perhaps time itself emerges from the quantum chaos. One leading idea is called the Wheeler-DeWitt equation. When physicists tried to combine quantum mechanics with general relativity to describe the universe as a whole, they ended up with this equation. And the most shocking thing about it, the variable for time is completely absent. It describes a static, timeless universe. This doesn't necessarily mean time doesn't exist, but it suggests that at the most fundamental level of reality, there's no master clock, no flow. The challenge for physicists is to explain how the illusion of time passing emerges from this timeless reality. So, how do we reconcile these two conflicting views? On one hand, Einstein's relativity gives us the block universe, where time is an illusion and the future is fixed. On the other hand, quantum mechanics suggests a universe of probability and uncertainty, where the future is open. This conflict is one of the biggest problems in modern physics. Could our perception of time's flow simply be a feature of our consciousness? Neuroscientists have found that our brain doesn't have a single time center. Instead, it pieces together our sense of time from various sensory inputs, memories, and expectations. Our perception of time can easily be distorted. Think about how time seems to fly when you're having fun, or drag on when you're bored. During a life-threatening moment, people often report that time slowed down dramatically. This is our brain processing information at an accelerated rate, creating more memories per second, and thus giving the subjective experience of time stretching. This suggests that our psychological experience of time, the feeling of a now moving from the past into the future, might be a biological construct, a trick of the mind that helps us navigate the world and make sense of cause and effect. Perhaps the universe is static, as the block universe theory suggests, but our consciousness moves through it, illuminating moments one by one, like a spotlight moving across a vast, dark stage. So, are we stuck replaying time? If the block universe is correct, then in a sense, yes. The story is already complete. Our consciousness is simply experiencing it sequentially. But this doesn't mean we're trapped in a loop in the way we might think. It's more like we are forever a part of the moment we are in. The you that was 5 years old still exists in that coordinate of space-time, just as the you of tomorrow exists in another. We are not replaying it. We are eternally being it. Ultimately, the true nature of time remains one of science's greatest mysteries. Is it a fundamental dimension, a stubborn illusion, or an emergent property of the quantum world? The answer might lie in a future theory of everything that finally unifies the world of the large with the world of the small. But for now, we're left with these tantalizing and terrifying possibilities. The fact that physicists are even asking these questions shows how much we still have to learn about the fabric of reality. What do you think? Is our feeling of free will just an illusion in a predetermined universe? Or is the future truly unwritten? Let us know your thoughts in the comments below. We love exploring these strange corners of reality with you. Thank you for joining us at the Bizarre Bureau. If you enjoyed this journey into the nature of time, don't forget to like, subscribe, and hit that notification bell so you don't miss our next exploration into the unknown. Until next time, stay curious.